Heyo, container dumplings! If you can't tell from the screen here, today I'm going to talk about singularity-compose, which is simple orchestration for singularity instances. So, let's get started. For those of you that are familiar with Docker, you're probably familiar with Docker Compose, which was actually my first entry point into this whole world of containers and services. And you maybe remember that there was this file called the dockercompose.yml that defined services. They had names. You could define your ports and your volumes and your links, and it was really, really cool. And so probably early 2016, since then I have been sort of wanting to do the same thing for Singularity. And lo and behold, we have come to a point where we are finally ready to do that. And so today I'm going to walk through this alpha release of Singularity-Compose. Why is it an alpha release? There's actually a pretty nasty bug. Where is it? Here we go. There's a bug currently with some networking firewall issues with Singularity to prevent different containers from talking to one another. It's not Singularity's fault, it's Docker's fault for messing with IP tables. So for now, this simple alpha release and the example I'm going to go through is basically going to use one container since we won't have that issue of cross communication. So let's get started. Here we are in the repo. We just technically cloned it, or you can imagine. The first thing we want to look at is this file akin to the Docker Compose. We have the singularity-compose.yml file. So if we look in here, the first section that you see is instances. And under instances, we have different named sections. So here is app, and there's actually only one named section. And this means that we're only going to be creating one instance. And so we can kind of read this like a story. We want to create an instance that's called app. We want to build it from this app folder in the present working directory. That's the context. And if we look in there, lo and behold, there's a singularity recipe. So I could actually put another parameter that says, okay, I want my recipe to be singularity tacos, but we don't need to do that because we're using the default, which is singularity, and it's there. You'll also notice that there's this app.sif, which I'm actually going to remove for now because I want to show you how to rebuild it. So let's say we just clone this, there's no app.sif, and actually there's no database there either because we haven't made it yet. Yes. Okay, so the first thing you do after cloning, you do some singularity-compose build to just build your containers. And by the way, this will build from a recipe, so it does require sudo, which I had already granted in this terminal. So while it's building, let's take a closer look at this particular recipe. Oh, this is a pip. Nope, that's the wrong one too. I'll just find it again. Singularity-compose simple. Yes, this is the one I want. Okay, so let's take a look at the singularity-compose while it is building. So when we look next, we see all of these volumes, and I want to point out that this is the starkest, most different thing between Singularity and Docker Compose. With Docker, you're root in the container, so you can just write wherever the heck you are. But when you do this in a read-only context, which is true of Singularity containers, you really start to realize the sheer number of places that you are writing that you don't have access to. For example, Nginx needs to write to this cache folder and to this run folder. And so what this means for Singularity is that every place in the container that we need write, we have to bind it to the host. So this app folder binds to code, which if we look over at the build here, it's compiling Nginx, that's going to be where we're installing our main code. This local static and images folder gets bound to folders that are also expected to have write for Nginx in var www. If we look up here, these are various files for the Nginx configuration. These don't necessarily need to be write, but they need to be in the container. We are also saying that the container needs to expose port 80 for Nginx. And then finally, this little extra section called post. This isn't something that's typical of Docker Compose, but it's specifically for Singularity Compose. What this is a section where you can write commands that need to happen on the host after all of the services are built and brought up. So in this case, I need to create these folders on the host that we will be uploading images to. To give you a little background on the Nginx upload module, what it does is it basically lets you upload content directly to the web server, and then the web server basically just hands it over to the other server. Okay, so we are finishing up installing Nginx over here. What else can we quickly talk about? Yes, so actually I'll hold off on that because we're done over here. So let's go back over here. What we've just done is we just built, and guess what? Here is our app.sif. So what would we do now? Well, we'd probably want to run our application. So we would do singularity-compose up. And when we do singularity-compose up, it's going to create the instance. We can, if we were really running this, we'd say, okay, did it work? Let me look at logs for app and just show me the last 30 lines, so just to keep it simple. Okay, it looks like our uski, I'm not sure how to pronounce this guy, uski worker was successfully started. And if we look in app, it also looks like we have an SQLite 3 database, so those things should be working well. But I want to show you some cool networking stuff first. So we're going to kill, as quickly as we brought it up, we are going to bring it down. We're going to bring down this instance app. And what we're going to do is we're going to bring it up again with the debug command. And what the debug command is going to do is it's going to show us what exactly is going on the back end when we run this command, specifically with what Singularity is doing. So this is pretty scary, but let's step back. What we see here is the Singularity instance start command. And most of this cruft here is actually all of those binds that I showed you before were volume. So just disregard all of these for now. The cool part is that if you look here, we see this net argument. And what that signals to Singularity is that, okay, this is going to involve networking. And what I learned yesterday is that Singularity automatically creates what's called a bridge. There's this thing called bridge control show. So if we do bridge control show, BRCTL, there it is. I can't spell. Okay, so if we do BCRTL show, this affirms my previous belief that there's a Docker bridge. And then what happened yesterday is I ran this command and I saw SBR0 and I said, oh, could that be a Singularity bridge? And in fact, there's an interface on it now. So if I do bridge control show SBR0, then that will filter down to Singularity. And what I see is that there's an interface running on it. So, this is exactly what happened yesterday. I said, I wonder if that is the container instance that I just brought up. The only way to test this is to bring it down. So then when we bring it down, what we'll do, so if this hypothesis is true, that in fact the instance app is added to this bridge, we should see this interface totally removed from it when we show it again. And that is indeed the case. So let's actually look again at that networking command because there's some other cool stuff I want to talk about. So right off the bat, so this signifies that we're going to do networking, add it to the bridge. And so the next thing we see are these flags for network args. And this here would, as you guessed it, will expose port 80. But what this is doing, if you look at the Singularity source code, is there's this plugin architecture, an API that makes it easy to work with networking for containers, and not surprisingly, it's called CNI, the Container Networking Interface. And so these are arguments that are getting passed to CNI to do all the sort of dirty work with IP tables and whatnot to handle making this thing work. And a really cool thing that I also figured out yesterday is that a bridge has a certain address space that we can actually predefine addresses for containers, and then we can give it to the container as a network arg saying, hey, you container, this is your IP address, you don't have a choice, tough luck. And the container then gets it. And then host name, we can also define the host name, Red Bull Tempest, etc. So that's the coolness of what's going on with bridges and with hosts. So let's bring our container up again because it's probably about time that I actually showed you the application that we create. So here it is, purple glory. It really is a simple example of this particular module with Django and Nginx, because that's something that probably a lot of people would be interested in. I made it a couple of years ago. So here's a picture called Bad Robot I don't even know what all these pictures are that I made, but so we just saw the entire thing happen. What happened was this particular image got uploaded directly to Nginx, and it took the hash and the size, and then it was redirected and sent to the server. And what actually happened here is that it was added to this images folder by way of this upload folder. And it might seem stupid for something like a PNG file, but for an actual container binary that's huge, this makes really speedy upload speeds. But I won't get into those details. So I already showed you how to do singularity-compose logs in case you want to see how something went wrong or didn't. So for example, here are the logs from Nginx that we just did. We see that we have a redirect and a 200. What else could we look at? Singularity-compose. Yes, before I forget, let's say that we looked at the logs and there was an error and it was all wrong and we're like freaking out. We could actually shell into our app instance and look around. Oh, which version of Python am I running? Let me look at the code folder. How's everything going? Okay, there's the database. And so that's a quick and easy command. Another cool thing you can do is exec a command to app. So, okay, that's exactly how that sounds. Oops. So that was just my stupidity. There's no such command as, I forgot the echo there. So just to make that clear, I executed a command mra that doesn't exist, and it returned a rather ugly error message that should have been properly caught, and I didn't because I'm a bad dinosaur, so I'll fix that up. So we can shell, we can exec. There's some other commands for sort of looking at a config, or another for create. A restart will basically bring it down and then bring it up. Oh yeah, and the PS, of course, is needed so you can see exactly what is running. So let me show you this quickly, the etc host. This is the other cool thing. I remember how I showed you that the IP addresses are sort of designated on before the instances are created. This means that we can create the shared etc host file that basically is then bound to every container at etc host. So I can prove this, singularity-compose shell app, and then I can cat etc host. There's the same file. So the idea is that if we had more than one instance here, we would have this list continued, and I could talk to the other instances from here by way of their host name. Of course, that's not currently working because of this Docker issue, so don't worry about that. So that's about it. I won't go into any more details. If you want to see more, I guess, information, there's a really clean getting started guide that I put together today in this documentation base. There's also a quick start that will walk you through this exact example and explain some of the networking. There's a page that will talk about all these various commands that you can do in more detail that I went through. And then also the specification will talk specifically about the sections in this configuration file, the singularity-compose.yml. So that's all I got. I will probably do another example when the full multiple container thing is working. And on that note, thanks everyone. Dinosaur out.